Hi, everybody. How you doing tonight? Sorry, it's a little slow on the uptake there. We're just trying to do a last-minute arrangement. Welcome to the virtual night sky. We've made it all the way to March, so this is the March 9th version of virtual night sky, and we have a great program tonight. So let me just tell you a little bit how things are going to go, and then I'll introduce my team. So we've got the first half of the program. We're going to get into the night sky. We're going to introduce you to some things to go look for. We've been spending a lot of time going over fundamentals so far this semester and this season, and so now we're going to kind of go out and practice, and that'll be the first part. And I'm going to share that first part with Armand, who's going to talk about visual magnitude, and Alex Blanche, who's going to kind of show us sort of how to find and identify some different magnitude stars in your night sky. So that'll be kind of fun. After a little break, if you've been following along, remember we've been doing the 5 things. So this is the night we're going to tackle the 5th of 5 things. And for those of you that are just joining us, you haven't seen the 5 things yet, we've covered 4. We're going to get to 5, and we'll do that. And then I have some very, very special guests. So a panel of guests we're going to talk to in the second half of the program. And you'll see how they relate to the 5 things and all of that as we get forward. Always joining me tonight, I always appreciate her help and support, is Kim Baptista. She's your webmaster. She does she gets your communications out, she gets you started, she gets this thing going. She makes sure that I'm on track. And so she's here tonight, of course. And my colleague Meg Hufford, Meg and I are community outreach people. We are about taking ASU and our amazing research and science and providing it out to the community of all ages, on all levels. We're doing that a lot virtually now, but we anticipate very soon, almost ready to announce, that we'll be back live on campus and do that. And so, of course, I've got 3 other participants that are share with us. 2 students is Alex Blanche and Armand Dalla. And everybody remembers Alicia Hyatt. She's a staff member now. She's an education specialist, and she helps in the background too. So as we're going through this, this is a webinar format, so we don't do chat, but we do encourage you to go in and do question and answer. If along the way you have anything you want to ask about, if you have any comments about what we're doing, if you have any sort of thing that's relevant to the show as you're hearing it, please just jump on and sort of get on board and do that. I really would appreciate it to sort of like just kind of work with us and be part of the program. And you'll do that through the question and answer button. We will also be running a sort of a closed caption. You're in charge of that. If you don't want closed caption on your screen, you can just turn it off. You'll be getting some information after the program and a little survey, and we really appreciate if you would kind of help us out and sort of show us, tell us what we're doing right, what we're doing wrong, what you'd like to see in the program in the future. So we've got a lot to get to, so I better start that. I also wanted to introduce, and let me just ask my team to look and see if they're here, but Mr. Canonic, Steve Canonic, is a Scoutmaster, and he and I chatted earlier in the week, and if I have this right, they are actually watching the program in their living room, and they're going to watch the first half of the show, so they'll like see some things to go look at, and then he's going to take his scouts and move outside and see if they can find some of the stuff we're talking about. So it is absolutely in the spirit of what we're talking about tonight. So if you guys are here and you're on board, Steve Canonic, I appreciate it, and hopefully I'll hear from you afterwards if all this works. So thanks for that. Let me see. I guess that's really where we're going to get started. I want to kind of show you a little bit about the night sky. If you guys have been with us before, you know some of the things, some of the technique I like to use is like talk about what's going on in space, and then what do we get to see from our backyard. So what do we get to see here? What's happening up there? How are planets moving around? Where are the stars? What's going on? And then for us, when we look up at the night sky, what do we have access to? What do we get to see? And how do we get to see it? I'm going to add something in the middle. I'm going to actually sort of say what's going on in space, and then I'm going to translate that to a star chart. How can we visualize that on a star chart? And then what do we get to see in the night sky? So I'm adding a little element. What's happening out there? How do we depict that on the chart? How does that show up? How can we find that as a reference, use that as a reference, and then what to go look for? Does that sound all right with everybody? Let's see, Rose or Alicia, if you wouldn't mind getting ready, I'm going to share a little thing first, And I just want to show you a little star chart here. Ooh, sorry about that. Hang on a second. It probably is because it isn't live. I'm going to stop share. One moment, please. I use, everybody sort of knows, I like to kind of use a little iPad when I'm doing some of these programs, and we use that as an iPad and a sketch pad and all of that stuff. And so sometimes it just doesn't connect exactly right to the thing. So please connect to Wi-Fi. Sure. I think I can do this. Just one moment, sorry, it's coming on just about now. So in front of you is a star chart that we use. We use this for our labs. And so you can go to our bookstore if you want, ASU bookstore, and you'll find these. They have some supplies they're supposed to get. And I just really like this one because it does two things for us. It's kind of what I call a super graphic. It shows the night sky in a lot of different ways. There's a tremendous amount of detail in this particular chart, and I'll show you some of that and how that works. But it also sort of gives you an overview of the whole sky. So just to sort of like get you oriented here, what's going on is that is the straight line that goes all the way across right to left is, I think I can use an arrow to do this, and maybe you guys can see that, is the equator of the Earth projected out into space. And so if you sort of imagine that some stars are in the north above our equator, some stars in the south below our equator, but depending on where we are on Earth, we have different stars that are passing exactly overhead as we go through our sky. And so our equator is done. The curved line, the sort of like sine wave line that goes down and up and over, that's the line of the ecliptic. And a couple of weeks ago, we were talking about the sun and how we see the sun in the sky and where the sun is against a background of stars. And so I wanted to kind of just show a little bit about where that is now. And then 2 weeks ago, we did talk a lot about the planets and what the planets are doing and all that stuff. So Alicia, do you have that image ready? Can you show it? I'm going to stop share if you can share.
No, Rick, I'm checking my inbox and I'm not seeing that image.
Oh, okay. So let me see, I'm not going to be able to sort of like catch up now. So if you were with us a couple of weeks ago, what we do is we show from space how the planets are orbiting the sun, where the Earth is in relation to the sun and where the planets are and all of that stuff. And so that's kind of a thing. We went over that quite a little bit and showed that actually most of the planets, as the Earth is looking at the sun, are to the right, way off to the right side. I'll tell you what, I might be able to show this here. Can you guys see this all right? Let's sort of open it up. There you go. Is that all right? Can you see that?
We're still seeing the same screen, Rick.
Okay, sorry about that. Never mind, I can share it. So this is what we looked at the other day. So here's the Earth in front. Now you're seeing the right one, right?
Yes.
Yes, it is. Okay, so here's the Earth in front, here's the sun, and you can see just peeking around behind the sun back there is Jupiter. Here's Mercury over here, Saturn way off in the distance over here, Venus and Mars. It's a little bit unusual that all of the planets are on the sort of the same side of the screen. If you were to draw a line right through the Earth and the sun, sort of like through here out to space, everything on this side of the line, on the right side, would be things that we see in the morning. Everything on the left side of the sun, sort of over there, would be things that we see in the evening. And of course, if these planets were behind us, or they would be seen during the night, but not necessarily evening or morning. And so this is actually kind of an unusual arrangement where everything seems to be clustered together. Everything's over on the same side. And so I'm going to stop this share again. We're going to go back to my little chart. I'm going to just show you how that appears on the chart now. So one moment, please. I got to go back to it. So if I zoom in here really, really, really closely, we're watching that line of the ecliptic. You see that there? And I think there's enough detail here. You can start to see there's constellations. You can see that, oops, I made a little green line. You can see all of the black dots are stars. They're black. The bigger the dot, the brighter the star. And you can also see that the line, the curved line that goes through the whole image here is actually marked in dates. So if I get to the sort of right place over here, I can actually do this little thing. I'm going to spend a little moment and show you guys where the sun is. I can actually just mark it right here. Can you see there's a March 10th, first right there, March 10th. I'm going to put the sun right here on March the 9th. Now, also, I want to point out here is that the sun is moving in this direction. And in just a couple of weeks, or actually less than 2 weeks, the sun is going to cross this point right here. That means it's going to basically go from below the Earth's equator to above the Earth's equator. And that magic moment is called the equinox. And so we'll see that in a couple of weeks. Our show 2 weeks from now is going to be about the equinox, and I'll tell you a little bit more about how to look for that. I took the trouble before the show to put all those planets on this chart. So you remember from the image, we got the sun, and then Jupiter was kind of right behind it, and then all the other planets were there. So I can kind of show you this here a little bit. This right here is Mercury. This is Saturn. This is Venus. And here's how what's happening in the sky can be sort of depicted on a chart, on a little map. And we can see the relationship between these stars, the constellations that they're traveling in, where they are. One of the key things here is to point out is that they're right along that line of the ecliptic. The ecliptic is the plane of our solar system projected out into space. We know our solar system is fairly flat. Everybody sort of sees it that way. Everybody sort of knows that. And so these planets will never wander above and below the ecliptic too much. You can see they're off a little bit, and that's all right, but they'll never get too far away. Mercury and Venus will never get very far away from the sun. So they'll either be on this side, towards the right side a little bit, morning objects, or they'll be on the left side, they'll be evening objects, but they never really get too far away from the sun. The other planets are free to move along that line of the ecliptic, go all the way around us and back of us. They can be seen any time of the night, but they will always be sort of traced on that line of the ecliptic. And so I just wanted to show you that because we were talking about planets last week and showing you that very unusual arrangement of all the planets in the same place, and that's how that works. The next thing I wanted to do is sort of suggest to you that there's a part of the sky that we don't get to see because of the sun's glare, right? Because the sun is so bright, there's a whole area of the sky that we just can't see at all. It just isn't visible to us. And then if I sort of made it clear, on this side of that sun's glare is morning, and on the other side of that sun glare is evening. And so you can infer from this chart that things over here are going to be morning objects over on this side. Things over on the other side are going to be evening objects. Things that are very, very close to that boundary, right there, are going to be visible in the west just after sunset. I mean, we get the sun's glare out of the way, and then you have stars that will follow and set right after that. And so that's this section of the sky over here. Way over here, though, is really the key of tonight's program. I'm going to make it green. I'm going to change colors so you can see where we're at. These are the stars that are up overhead directly to the south, highest in the sky right now. That makes a little bit of sense because if the sun is in the sky directly overhead at noon, about 7 hours later, which are marked at the top of the screen here, is about now. And these are going to be the stars that are directly overhead tonight. And when we close out the show tonight, you go outside, it's a perfectly clear day. It's a beautiful evening. You can go out and kind of look at this part of the sky. Over here, oh, one more thing I wanted to show you from the map, if it isn't too crowded yet. Remember, I was talking about star brightness can be seen on this particular chart. Dark dots, big black dots are going to be bright stars. Little tiny dots that are very visible are going to be dim stars. And this particular circle I've drawn is a collection of very bright stars. It's an unusual part of the sky. It's many, many constellations, but a large number of what we call first and second magnitude stars are available, are visible in this part of the sky. Happens to be up right now because of the position of the sun, where the sun is just before equinox. 7 hours later, the sun has gone down, it's dark enough to see, and these are the stars that are overhead in our sky. I'm just going to circle all of these little constellations we're going to be looking at tonight, and then I'm going to turn the microphone over to Armand. So this is Orion. Here is Canis Major, the big dog, Canis Minor, the little dog. Two constellations of the zodiac. Taurus is here. I'm a Taurus. Gemini is here, and Capella up at the top. 5 big major constellations encrusted with really, really super bright stars. Fun to look at these in this time of year and this time of the evening. Okay, I'm going to back off, stop my share, and I'm going to ask Armand to come in and just kind of talk a little bit about magnitude, brightness of stars, where it comes from, and how it works. Thank you.
Thank you, Rick. Let me get my screen shared and let's get started. All right, I want to start by showing you a picture of some stars. You can see that some are dimmer and some are much brighter than others. But how can we classify and compare these stars based on their brightness? Well, we do that through stellar magnitudes. And the first person to sort of classify the stars based on their brightness was an ancient Greek astronomer named Hipparchus, who lived around more than 2,000 years ago. On his scale, stars classified as 1 were the brightest, and stars classified as 6 were the dimmest stars. And I want to mention that the scale is not linear, which means that the difference in the brightness between each magnitude is 2.5 times that of the previous one. So for example, a 6 magnitude star is 100 times fainter than a 1st magnitude star. Remember, as you go up the scale, the stars become fainter, and as you go down the scale, the stars become brighter. In Hipparchus' time, he didn't include the sun and the moon in his observations because they were obviously much, much more brighter than all the stars in the sky. But with the new advances in technology today, like the telescope, we're able to see not only stars brighter than what Hipparchus was seeing, but also stars much, much fainter than what he was seeing. So we're able to expand the list out much more. We can see that the sun has magnitude of -27, the full moon has magnitude of -13. Sirius, the brightest star in the sky, has a magnitude of -1.5. The dimmest star we can see has a magnitude of 6. Remember, that was how far Hipparchus' scale went. And if we go into the really faint objects, we can see that the objects seen by the Hubble deep field observation had a magnitude of 30. And remember, each difference in magnitude means that the object is 2.5 times brighter or dimmer than the previous magnitude. So just imagine how dim the objects that Hubble saw in the deep field observation. But everything we've talked about so far has come from apparent magnitude, or how bright a star or object appears to us from the Earth. But we know that there are 2 factors that affect how bright a star is. One is its luminosity, or how much light the star emits. And the second is its distance. We know that if a star has a big luminosity, it emits a lot of light. It's going to appear brighter to us. And if a star is really far away from Earth, it's going to appear dimmer. So how do we actually compare the stars? Because if 2 stars appear similar to us, one of them could just be incredibly far away but have a massive luminosity, in which they would appear the same as a star closer to us, but with a smaller luminosity. So we are able to compare stars by using absolute magnitude, which is how bright a star would be at a distance of 10 parsecs. So for example, the sun's apparent magnitude, or how bright it is from our viewpoint, is -27, but its absolute magnitude is positive 4.83. Remember, the dimmest stars we can see with our naked eye is around a 6, and the sun's absolute magnitude is around a 5. So that just gives some more context about how our sun compares to other stars. And speaking of other stars, I'm going to hand it over to Alex now, who's going to show us more about what stars we can see in the sky and what different magnitudes there are. Thank you.
Thanks, Armand. Hey, Alex.
Hello, hello. Let's talk about some of what Armand in the night sky, in our night sky. I'm going to share a little program with everyone. This is Stellarium. It's been featured on our program many times. It's a free program. There are links. Stellarium.org is a great place to check this out. This is our sky right now. And what we're going to talk about is we're going to talk about how magnitudes, these numbers work in terms of, more of what we can see. Right now we're viewing the night sky in a level of light pollution that's pretty similar to like more downtown Phoenix. So this isn't the clearest sky. As you can see, there aren't many stars, but we're going to lower it a little bit just so we can see some more for a better comparison. So let's talk first about some of the brightest stars you can see. These are either going to be first magnitude or even kind of above that. These are stars like Sirius. Sirius is one of the brightest stars we can see in the night sky. One of the brightest stars we can see in the night sky right now, and just in general. We also have stars like Beetlejuice in the constellation Orion, Rigel, Procyon. These are all magnitude 1 stars. These are all very bright stars. When we actually look on them, they have magnitudes of about -1.5 or above. And so these are very, very bright stars. Betelgeuse actually has about a half. So it's a little bit dimmer, but it's still within the range where it's one of the more easily identifiable stars in almost any amount of light pollution because of how bright it is. Then you also have stars like Castor and Pollux right above it. This is almost directly ahead in our night sky. These are also kind of magnitude 1 stars, very, very bright and identifiable. And so these are great stars to see almost anywhere because you're not going to see them really affected by light pollution very much. Let's see.
I guess we should point out the moon is in the sky tonight too. So
the moon is also in the sky tonight. Yes.
Yeah. So it's kind of like it's going to obscure our view a little bit. So that's a kind of a good note for the scouts that are going to go out and look at the sky. So the moon is also, but the moon is not full. It's like it's still less than a quarter, so it shouldn't hurt you too much.
Yeah, and right now it's magnitude -10 about. So it's a lot brighter than even some of the brightest stars. But then we also have stars like Capella, which is another very, very bright star. But you can see that there are also some of these dimmer second magnitude stars. Like if we go over near Procyon, I believe it is. Yeah, Procyon. You'll notice that there's actually a very dim star nearby that starts to fade out once we get into higher light pollution. It makes it very hard to see just because it's of a much lower magnitude. And so this would start to fall into the category like 2 stars. And then these final category 3 stars that we talk about, these are the last ones that are going to be visible to the human eye. And these are going to be in, even in the best kind of dark skies, these are still going to be very difficult to just see because that's just the limit of our eyes at that point. But category 1, they're easily visible almost anywhere. Category 2, you need decent skies to be able to really see well. And then category 3, you just need good skies and good eyes. So, this is kind of what you can begin to see, but look for the category 1 stars tonight. You can see them almost all the time. Betelgeuse and Sirius are really easy to find because they're near that very definitive constellation of Orion with the 3 stars in the belt. And then you can just look up in that kind of right above you and see the stars of Procyon and Castor and Pollux and the moon. So yeah, be sure to check those out because those are stars that you'll be able to see almost anywhere, wherever you are. So Yeah, of course, if you get the chance, go out somewhere darker and catch those category 2 and category 3 stars as well.
Alex, I'm going to ask you to like point something out. So do Beetlejuice and Spica again, or Sirius. Sorry, it's Beetlejuice and Sirius, and Procyon. Just draw a little triangle there. So basically, you've got from Procyon. Oh, you can draw Sirius, Beetlejuice, and so the two big distinguishing, sort of really recognizable asterisms, if you want, is the sort of the constellation of Orion. It's easy to see upper stars, the lower stars, the belt that divided in half, and then Betelgeuse is the anchor of a triangle. And so if you start find those, you know you're in first magnitude territory. If you can see the dimmer stars, the other shoulder of Orion, Bellatrix, and the lower other side, Saph right there, those are going to be second magnitude stars. And so that'll kind of give you a sense. If you can see the little knife hanging off the belt, then you've got really good eyes and you've got some fairly good seeing, because those are going to be third magnitude stars and below. And so this is a really good part of the sky just to look at and get a sense of how much moisture is in the air, how much moonlight is affecting your view, how much the street lights are affecting your view. And for the scouts that are looking at these tonight, if you go on camping trips, of course, these are really, really great stars to look at, really great constellations to find, and you'll see it a lot better and a lot more stars than you do in the city lights. So there's your assignment. Go out, so use these patterns of stars in this particular part of the sky, this abundance of really bright stars to get yourself oriented, and then start digging deeper and deeper and deeper, really, really close to some of these things, and see if you can see some of the second, third, and maybe even fourth magnitude stars as you sort of look at this area. Thank you, Alex. Thank you, Arma.
Yeah, thank you, Rick.
Great presentation about magnitude and starlight and this stuff. We're going to take a little bit of a break here. We've got time to just have a couple of questions. I'm going to launch a poll. We have a 1-question poll for everybody tonight, and to kind of give away what we're going to be talking about in the second half of the program. Alicia, do we have any kind of questions to work on here?
We do. Before I launch the poll, I would just like to remind everyone to go ahead and submit any questions that you may have for Alex, Armand, or Rick. Thank you so much for those wonderful presentations on magnitude. We have a couple of questions so far, and one of the common ones we have is from Stuart, and it is there rule or logic when parsecs are used rather than light years?
Oh, that's a really good question. How would you answer it, Alicia? I have my answer.
Ooh, I would say it's all on distance, right?
I think it's just kind of, it depends on sort of maybe the research you do. So there is a direct corollary between light years and parsecs. So a parsec is I don't remember the exact number, but it's about 3.15 or 3.16 light years. And so they kind of translate easily. Parsec actually relates to kind of a parallax of a movement of a star. And so it's how far you have to be to see a star in parallax move by an arc second, a parallax second. And it just happens to be that distance. And so back in the days when researchers were really sort of refining how far these things are away from us, the closest stars, the distance was out to a certain point, that was a really simple way for them classify them together, because they were all discovered by parallax, determine where they are, and that particular formula comes right from that. So that's what I would use parsec. They use it in Star Trek too, don't they? It is,
well, thank you for that. And I am going to launch our poll now before I take another question for Armand or Alex or Rick. And our poll is now live, and it says, did you have a teacher in high school who had a positive impact on your life? Yes or no? And we're going to talk about why that's important in a minute. But while you're filling out that poll, let's see if I can pull up another question from the chat. Patricia would like to know, does magnitude on modern brightness curve on an exponential scale or a logarithmic scale or other? And that is a pretty in-depth question.
It's a modified log scale, and I think Armand mentioned in his talk that it is standardized by 5 magnitudes being 100 times the brightness. So if you go from a 5th magnitude star to a 0 magnitude star, the 0 is 100 times brighter than the other. And so that divides out to, you'd have to sort of do the exponents, but it's 2.53 times 2.53 times 2.53. You do that 5 times and it equals 100. So it's that's kind of how it does it. So good question.
Wonderful. Well, and our chat is, or excuse me, our question and answer is just going crazy. So between everyone behind the scenes, we'll try and answer those questions. And going back to our poll, it does look like almost all of us do have remember a teacher that left a positive impact on our lives. And that's wonderful. I know I definitely have my fair share of teachers that I am so thankful that I had. So Rick, do you want to explain why that was important?
I do, but I'm going to go to the 5 things. So here, let me just kind of get everybody up to speed, and then you'll see why this makes a difference to us today. Thank you. And that's kind of what I expected to see, right? The vast majority of us had some sort of amazing experience with a teacher. As I did, my 7th grade high school teacher, Mr. Locker, actually sort of was so easy and so wonderful and so inspiring. It sort of made me think about the sciences for the rest of my life. And you're going to see here in a minute that rubbed off even farther. So I wanted to kind of just give everybody this idea of 5 things. We've mentioned it before, and it really came from a talk sort of about how our calendar, how our systems, how humans came to be, how civilizations formed, happened under a sky that had astronomical phenomenon happening. And over time, we sort of like used to be all agrarian people, and now we are all city people. Not all, right? So, but 200 years ago, pretty much everybody worked on the farm. And today we are kind of in our hustle and bustle city life and going to school and doing our things. And the clock we use is, I argue, a bit artificial. The real clock we should be attaching ourselves to is that of the movement of stars and planets. And so I kind of developed this thing called 5 ways to reconnect to the meaning of time. If you've been watching over the first part of the year, remember the first one I said is just basically watch the annual cycles. Get to know a part of the sky, like the ones we just showed you tonight. Go out and look at this same part of the sky next March and the March after that, and you'll see year after year after year, the same stars come back to visit you. The things that you learned, the things that you observed, are observable again. Go out and see them again and sort of watch them come back. I also suggested that we work to actually see things that happen periodically. You hear about a comet and just get out of town and go look for it. Take some binoculars, go see it. If there's some phenomenon that happens at 2 in the morning, get out of bed, put a jacket on, get outside, look for it, right? So the periodic things are important. Sort of cycle in the annual cycle, but also there's part of the sky that happens on a much, much, much bigger scale. The orbits of comets and meteor showers and eclipses, all of that stuff, this phenomenon is available to you, but you kind of have to work to go find them, see them, and make that happen. I suggested in number 3 that you change habits seasonally. We sort of do that anyway, but do things differently one part of the season and the next. Eat different foods. And I suggested, I think a couple of weeks ago, that if you're into the farmer's market craze, you're already doing it. You're buying something at a farmer's stand that grew in the sunlight this week. And that's meaningful, that your body craves that, you want that, sort of, make the seasons actually sort of work for you and change your habits and things like that as you go. So just kind of get into the spirit of that. The next thing I said, and this is what we covered 2 weeks ago, is be an advocate for dark skies. Right, Armand and Alex talked a lot about what you can see and what you can't see. This time of year we have bright stars. Yeah, that's really great. But what about the times when there aren't really bright stars out? What do we get to see from town? And so there are ways to kind of get to your city council and talk to your people and talk to your neighborhoods and actually sort of advocate for sort of keeping our skies as dark as possible. There's a movement afoot, and it's really, really fun to do. The last one we haven't covered yet. So tonight I am announcing thing number 5. And to me, it's probably the most important. What you do in thing number 5 is you do all of those other things, all of them 1 through 4, but you do them with a child. And that really sort of is succinctly covers the 5 things that are going to keep us connected. And it allows me to introduce the guests for the rest of the program. Let me turn off the share here. So tonight with us, we have Cal Manus. Cal Manus is a lifelong educator. He's a person that sort of works in the informal education. He's right now in rural Arizona doing a star party for a group of young people. And so we're going to have him on. I've got 2 classroom teachers. Terry Villa from is with us tonight. And I'm just going to look at her, wrote down her school, and from Garden Lakes. She's a science teacher. She's been there for 24 years. A West Ridge Middle School from Austin, Texas, 7th grade science teacher. It's my daughter, Rosie Alling. And so she's going to be with us tonight as well. And then we also have Desiree Kroll, who runs a program that deals with mentorship at the university level. You've heard about it a little bit, the NASA Space Grant Program. So I want everybody to kind of welcome to the screen these 5 players. Am I still sharing? Let me just stop share there a little bit. These 5 players, and for the rest of the evening, we're going to kind of just talk a little bit about mentoring and education and what's important. And so earlier, just before we took the break, I saw that Cal Manus was on. So Cal, can you sort of unmute and come on board and tell us where you are and what you're doing up there?
Sure, thanks. A little out of breath because I've just packed a Star Lab into a small bag.
so your party is over?
Party's over. We had, I don't know, a little over 100 people show up, so that was kind of cool. We're just outside of Sholo, Arizona, at a small school called Sequoia Village. And we did a family STEM night with a mobile planetarium as one of the pieces. It seemed to have been the most popular. So, something that we have found to be true in general.
How many people does your little planetarium fit?
We sit about, it's a 7-meter diameter at the bottom, so sits about 40 people.
Okay, good. And so a night like this, how many shows did you guys have to present?
We did 2 hours.
Okay, good.
I did 20-minute shows. Didn't stop talking for 2 hours.
So just a little bit about what drives you, because I know you put a lot of miles on your car, and I know you cover a lot of territory. But what drives you to these remote areas of Arizona to do this? What makes that important?
So I started off as a high school science teacher in the White Mountains, actually, rural Arizona, and transitioned over to doing research funded by the National Science Foundation on formal and informal STEM learning opportunities in rural, remote, and tribal areas. And so I've been working the last 6 years on developing ecosystems, learning ecosystems around STEM outside of urban areas. So lots of miles go on the car.
I love it. And so, and how do the youngsters respond to do they just love this? It might be their only planetariums they get to see, right?
Yeah, so it's not unusual for kids in these areas never to have left the mountains. So many times these unique opportunities are really unique and incredibly special. And so they make a huge impact when folks bring projects into the rural communities, because the local folks really see how they're valued, right? They're not seen as them or outsiders, but that they have value. And so astronomy, I have found over the years that astronomy programs are universally welcome. Doesn't matter the type of community. If you have an astronomy program, it is amazing the folks that will show up.
Yeah. That's absolutely, and these youngsters have access to night skies that are way unlike anything out here in the valley.
Yeah, it's definitely dark skies here. So we can actually see the Milky Way. So
Yeah, of course you can. That would be great. Yeah, and if you've sort of watched the first part of the program, this that changes the metric. I mean, you got to probably regularly see the 5th and 6th magnitude stars up in that area. Well, I just think that's amazing, and I'm glad that you found this tool. And to let everybody know, Meg and I and the community outreach team at ASU, we've had a really good relationship with Cal over the years. We had a planetarium that we also used to lend to him, and sort of we got that going. And so we love following what you do, Cal. We love that you get out there and you do these special programs and you have a big impact on youngsters. That's really the point, right? It's just sort of, let's take this excitement and the knowledge that we have and it just, and make sure that the next generation has the same.
right, it's up to us to make it real.
Yeah, it absolutely is.
So
Cal, thanks. I'm gonna, if you hang on for sure, but I'm gonna move on to our classroom teachers here for a second. But hang on, maybe we'll sort of like bring everybody back in for some questions and stuff. So
Thank you, Cal.
So Rosie Alling, how you doing?
I'm doing well.
Good to see you.
Yeah, you too.
So, and can you tell just a little bit about what area you teach in? Because it's not necessarily astronomy, but it's STEM sciences in 7th grade, right?
Right, correct. So I teach 7th grade science here in Texas, which is life science. So my background, sorry to disappoint you, all you astronomy people, but my background is actually biological sciences. So that was actually what I did my undergrad in, and then I have my field experience and work experience in biological science as well. So I'm lucky because I found this little niche at in Texas 7th grade sciences, purely life science. So I love it.
That's excellent. Very, very good. Terry, I don't know if we just lost you. Are you still on?
I did. You did lose me briefly, and I am back. I apologize for that.
Thank you.
Yes,
Thank you.
yes.
No worries. So Rosie has been teaching now for how long?
This is my 3rd year.
3rd year. And
I have to think about it because COVID made it feel like 2 years were in one. So I always think I'm in my 4th year, but I'm actually my 3rd year.
But you're back in the classroom and this is back to normal. Okay. And then Terry, I think you told me you've been teaching for 24 years. And what's your specialty and what do you love?
Yes, so I've been teaching for 24 years. I've taught many different grades. I've been teaching 5th grade for about 7 years, specifically science. This year I took on social studies as well, but science is my passion. I'm learning right along with the kids, but being connected with you guys at ASU and the program you guys have has been phenomenal, even with the COVID that we had. We were in partnership before COVID, and during COVID we just made it work. And my passion is science, and what you guys do is phenomenal.
We can't wait to get your kids back on the campus. So
me either.
I just have to say, so can you guys recognize like the spark when some kid just sort of like, you can see they like get it, and it's going to be meaningful? Do you have a story? Do you have a sort of an antidote?
I do. So I have, so last year during COVID, I did hook up with you guys and we did a Zoom presentation with my class through Zoom. And that brother was so excited about what you guys presented. Well, I have the sister this year as well, and they've been connecting. So it's been a family event that they all connect onto you guys, onto your sites. They go outside. I know that the boy wants to, further his education, and he's a 6th grader now, and further his education in space. A couple years ago, again, we've been doing this for a couple years, you and I had another girl who we talked about. This is when we were having Perseverance landing on Mars. And I remember telling the kids back then, that think about it at their age, by the time they're of age, they might be the people landing on Mars because of their age group, you know, so there definitely was a connection with them. And very many, even to this day, they're so excited because we keep spiraling back to space. Even though I teach the other parts of science, we spiral back to space all the time. And what you guys are doing keeps them engaged and curious to learn more.
We'd love to be a part of it. Rosie, when can you tell that a student is like really, you know, kind of like getting engaged, or you found something that sparks their interest that might last for a long time?
Well, you caught me on a good day because we had, so today, so I have in our 7th grade science classes, we only have one 7th grade science course option. So in every given class, I have everything from our gifted and talented students, many of whom already have scientific interests, to our, you know, special ed, learning disabilities, cognitive disabilities, all in one classroom. And so we do what we call universal design learning. And so in any given day, especially for our harder concepts, like right now we're learning genetics. And so in any given day, we have multiple activities, almost like stations that students go to, depending on where they need review, or if they want kind of an extension activity, like if they've got the basics, they can move on to something kind of like take it a little step further. So today, actually, we were doing that because I have everyone some kids who can't figure out a basic Punnett square to kids who are doing dihybrid crosses and
You lost me.
I know, and doing computer simulations where they're breeding fruit flies for specific traits and all of that. So we have all that in one class. And today it was amazing because without me saying anything, I actually had some of these more advanced students that were just naturally going to some of the students who are really struggling, and they were teaching them without me telling them to do anything, without those students asking, because they saw that need and that interest. And so, and that ended up making them way more interested, because I'll tell you, a kid wants to listen to another kid trying to help them way more than they want to listen to me trying to help them. So that was really great to see. And then I even had one girl afterwards, she's like, wow, that was really fun. Maybe I should be a teacher. I'm like, but it was really, really awesome to see.
Terry, did you have any, you've been a teacher for 24 years, any regrets?
None.
You expected, you wanted to do this?
None. I will say this last few years have been quite a struggle, and this year has been no exception, but no regrets. I've learned right along with the kids, and we go with the punches, we go with the challenges, we accept them. And some days are successes, just like science, and some days are not so successful, but we learn and we figure it out together. You know, the parents, the students, and myself. So no regrets, none.
Rosie, I know you did field work and did some work in the South Seas and some places, but what made you just sort of say, okay, I'm going to end up as a 7th grade teacher?
Well, actually, and what Cal was talking about made me kind of think of this, because before I decided to go into teaching, I was a biological science technician at Mount Rainier National Park. And it was what you would think, for most people, it's a dream job. I got to hike around all day. I got to go camping, go to really remote parts of the park. It was amazing. But we actually had a STEM day where some of the students, inner city kids from Tacoma and Seattle area, came up to Mount Rainier. And so these were city kids coming rural, but some of them had never, Mount Rainier's not that far away, or they had never been to a forest, or really even anywhere beyond maybe like a park on their city block for the outdoors, and seeing their excitement and just like awe. And it kind of made me think, yeah, maybe that's teaching kids and giving them more experiences, and science experiences, something that I wanted to do.
I've heard the story about working through the struggle of COVID, and sort of everybody sort of has to adapt. And I've heard how hard it is to try to do both in class and hybrid at the same time. So let's hope that's all past us, and let's hope you guys kind of I think you guys are our heroes, right? I really think that you've sort of chosen a profession that I think is so important and so honorable, and it's what's needed. So that's why it kind of lives in my five. We're not going to keep any of this ancient knowledge or this connection, this really way to sort of interact with nature and space, unless we pass that on, unless we sort of make that happen. So you all do it in special ways. I'm gonna have to hang on, okay, so hang with us here a little bit, but I wanted to introduce Desiree, and so she can give a little talk about what she does and how she interacts with young people. So Desiree actually she's earned a Bachelor of Science in Business Administration and Marketing at Ohio State University. She says the Ohio State University, so I think she's proud of her place. And she's been working in higher education for 33 years. I can't believe it. She doesn't look like she's more than 29. She says, though, she started as a sophomore. I met Desiree about 6 years ago, and she's in and around my building. She works at the School of Earth and Space Exploration, but she has a really, really special program. She's the program manager for what's called the NASA Space Grant. So how do you interact with young people, and what inspires you, and what makes you go home at night saying, oh my God, that was an amazing success?
Well, I'll tell you how I got into this. I mean, like you said that I got the degree in marketing, but how did I get to space? So it's been a ride, basically. So after I left Ohio State, after I graduated, I went to Tulane and I started working there. And I started working in the Department for Cardiovascular Health, Cancer Research, Anatomy, embryology, and things like that. So I got the science book and I started taking classes to help me understand everything better, like genetics, cellular molecular biology, virology, and things like that. So, which is something I was interested in before I graduated, but I still was interested in it. And then after I left Tulane, I went and worked at Georgetown in Washington, D.C., where I ended up with getting more experience in web development. And so I helped maintain the database for all the proteins that have been sequenced in the Human Genome Project. So I'm still on the science part, but then I'm headed into computers, but I'm still in an administrative capacity. And then how I got to the step before space grant, I went back to, and to be honest, is the title of the Ohio.
Oh, it is?
Yes,
Okay.
it is. We actually put out something to trademark the word "the," but the government kicked it back. But anyway, they said you can't own that word. But anyway, so when I went back to Ohio State and worked there, I worked in the graduate school and I ran programs that are very similar to Space Grant. One was for underrepresented minorities in the state of Ohio that were all a part of a 15 institution consortium within the state. And then that was the Lewis Stokes Alliance for Minority Participation. And then the other one was the Summer Research Opportunities Program, which is for underrepresented students as well, but it's from all over the country and Puerto Rico. So what we were doing were giving them internships, paid internships to come during the summer and do their research alongside a faculty mentor, and possibly within hopes of them enrolling and going to graduate school at Ohio State. So that brings me to Arizona, which is what the NASA Space Grant Program does, is students apply for an internship and they are paired with the faculty mentor. They choose a faculty mentor on a project that they want to work on with the mentor. And it's usually something that the mentor is already working on. And they do this research for an entire year throughout the academic year. Meg, if you don't mind, can you go ahead and share the screen and show the slides? I kind of went ahead of myself. So basically, this is, I'll tell you about NASA Space Grant, next slide. So this is what it is. It's Space Grant is a NASA-funded education and training grant that supports STEM education, but they also promote diversity. So if you look at what a scientist typically looks like, and that is what you see on TV for the most part is a Caucasian man, older man, gray hair, things like that. So they're trying to change that narrative and get a more diverse workforce working for NASA and in aeronautic fields. So what they do is they funnel funds to us through the University of Arizona to provide these internship opportunities. And there you see at the bottom of some of our interns working on some of their projects. Next slide, please. So here are some of the ways that we support students. We have undergraduate internships. So, and everything is a STEM-based internship. So you could be just a student doing an individual project with a mentor, or you can be doing a team project, a team research internship. And the images that you see here out in the desert is our Ascend program, where we launch a high altitude balloon. We fill it up with helium and launch it about 100,000 feet up in the air. And it has a string attached to it with payloads attached to it. And these payloads have different kind of experiments in them, and they capture data from the near Earth atmosphere. So, and then it comes back down and we gather the payloads and then see what kind of data that we captured from the mechanisms that's on the payload. And then another opportunity we have for graduate students is the graduate fellowships, where it's more of an informal education project. They might go into a school and have some kind of curriculum designed to teach K through 12 students about different concepts in science or engineering. So that's more of a hands-on activity. It's a full year activity. And then that is a paid fellowship as well. Next slide, please.
It's great that this is available.
Yes, it is. So this is the 2 eligibility criteria. You have to be a US citizen and enrolled full-time at ASU. A lot of people ask, well, what about GPA? Even though GPA is important, it will not necessarily prevent someone from being accepted in the program. What we look at when we look at transcripts, we look at your entire body of work. So let's say you struggled a little bit in a STEM class, but you made up for it later. We take that into consideration versus some programs where they say, oh, they just look at that number and make a hard decision off of that number. We don't do that. So this is the stipends. The students are paid $1,600 per semester, or $3,200 for the year for the undergrads. And for grads, it's $9,600 per semester, plus a tuition waiver and health insurance. Okay. And that's quite a nice package there. So as far as the mentor support, I'm sorry, go back, please. Uh-oh. It's like we have a problem. Houston. Well, I'll just keep talking.
Yeah. So we're actually kind of running with it. So we can
okay.
kind of wrap.
Okay. So
sorry about that.
Basically, we want the students to pair up with a mentor again to do research with that mentor. And what the students do at the end of the year, they present their research in a poster session and at our symposium. And they also have to write abstracts and things like that, and do informal education. They have to do 20 hours of volunteer work doing things with the public to promote STEM, NASA, and their research. So
many of those students help us with our program. Is it ever trouble finding a mentor? Do mentors like just
Sometimes a student may not know exactly what he or she wants to do. So they might have problems finding a mentor in that capacity, but we'll usually try to lend a hand and help them. But it's easier if a student comes equipped with a mentor, because when they apply for the program, the mentor has to apply as well. So it's a reciprocal application where the student names the mentor and the mentor names the student. So.
And back in Rosie and Terry's world, right? Students are making those decisions. They're kind of making a decision what they want to do then, or we're trying to get them to make that decision. Mm-hmm. So hopefully they're they're inspired by some sort of STEM thing or a science thing, and then they're going to go to a university, and there's a way to sort of capture them and pair them again, that sort of mentor-student relationship that I think is really, really vital. So they can just take off. And those students, I know several of them. Actually, Alex Blanche.
Alex is one.
and so that I think that's actually sort of great. We've seen a lot of them come through. Well, all of you are very special. Cal, if you're still on, you all do this in your way. You all dedicated to just this spirit of kind of making these amazing possibilities available for students. So I guess I'm going to leave it. If everybody can just, if Cal, if you're still on, just when you go home at night, right, and you say, oh my gosh, that was a successful day. That was the successful one, right? Rosie, I think you described it today. But are those few and far between, or do you sort of do you kind of live for those little successes all the time?
I don't get a chance to live through them. Basically, it's because I move on to the next thing. I don't get a chance to
always the next best coming.
I just move on to the next thing.
Terry, what makes you, when you get home at night, say, oh, that was it. That was the one. That was the amazing experience.
Yeah, for me, I'm always surprised by something with the kids. Even, we have moved on to talking about atoms and the periodic table, but again, we weave space back in there. We're still talking about the moon phases and going outside. And what excites me is when I hear from the parents that their kids are going home and talking about things that we're discussing in class. And it just warms my heart to know that the kids are just excited to be learning about science. And some of the things that I sometimes don't know whether they're absorbing it or not, or if they're just kind of like, okay, yeah, teachers, yeah. And then to hear from the parents that, oh no, they're talking to us, they're explaining things. That warms my heart. That's when I know I've made a difference, when I hear from the parents.
Rosie, does that happen for you?
Yeah.
How do you know?
Yeah.
How do you know when it's sinking in? I guess you have a great experience today. So
well, I mean, it's for me, I try to just day by day, because especially 7th graders, one day they're on, and then they might have 2 days that they are off on a different planet. But, as long as I can get to them little bits at a time, then it's a success.
it's a difference over time. Cal, are you still with us? You have a final comment?
Yeah, sure. I have, like the others, it's always very cool to see a huge smile, or when grandma, grandpa, and their grandkids are all talking together about the experience, then you've made an impact. A lot of what my work does is engage the community, because the folks that vote are the adults, and I want them to be as in the communication with their kids and with each other. So when folks are talking, I think that is a huge success.
Well, I appreciate it, and I think we'll sort of make this at least an annual thing. And so we'll call it our tribute to the educators and the teachers that are making all this work. So thank you all for being a part of the program tonight. I really appreciate it. I have some, at least, sort of relationship with all of you at some different levels. And Terry, I can't wait to see your kids back in our school. So we'll do that as quick as we can. And Rose, I'll see you soon enough. So thank you. Thanks for finding time to join us and sharing your thoughts. So thank you, guys. We are I'm just going to kind of come to a close. I do have another announcement to make, something coming up, and we do this about twice a year too. So I've just got a quick little video I just wanted to share with you, and then I'll make some comments about that. Let's see, who's doing the video part? Is it,
I was having some technical difficulties, but it looks like
this tonight we've been perplexed. Okay, there you go.
there we go. Hopefully you're seeing my screen here. But thank you so much to our educators and all of our guests that were here tonight. We just heard about how they are able to support students. And if you're wondering how you can support students or support the School of Earth and Space Exploration, this week's resource is for you. We have a couple of different options that we have on our website, and that will be in this link that Kim, our wonderful webinar queen, will send out. But this video kind of explains it better than I can. And so I'm just going to play it for you, and then I'll let Rick follow up.
Thank you.
You know, our school is really committed to scientific discovery and exploration of the Earth and the solar system and well beyond the solar system. We're involved in something like 24 spacecraft missions, mostly NASA missions, but also missions that are sponsored by other space agencies across the world. Our researchers are involved in the very kind of latest and greatest in terms of exploration. The main thing that I want to emphasize is that donors to the university and the programs at the university, you can really make significant advances, but also just in terms of making sure that you're ensuring the success of our students who are going to be the future of our country. This is just a really great time to be involved in any kind of exploration and scientific discovery.
Love that. So I really just wanted to point out, and we don't do this ask very often, but it is something we do need to do. Our program, our community outreach program, and you heard a little bit about its impact in Terry's school, for example, and our work with Cal and our support of him going out in the rural areas, that actually can't be covered by tuition dollars, and it can't be covered by research dollars. And state funding doesn't go that far anymore. So it's kind of funny to think ASU was a really, really big, gigantic, huge institution. But the work that we do is not automatically taken care of in this particular by regular funding sources. So there is an event coming up, happens once a year. We call it Sun Devil Giving Day, and it's on Thursday, March the 17th. You can remember it because it is St. Patrick's Day. And there's ways to get involved in that. You will get a little note at the with your sort of the end of recap and all that stuff. And you just want to take the trouble, just kind of go in there and take a look. Like all of these things are really, really easy to do now. And so remember, you can do it anytime. You can get the link and do it anytime. But our special day, when we're trying to focus their attention and trying to get as many contributions as possible, is coming up next week on the 17th. I really appreciate everybody's joining us and your support for our program. Sorry, we're running long again. We should just make this an hour and 10 minutes and just get over it. Next 2 weeks, I alluded to it before, the spring equinox, the vernal equinox, is going to be about 2 days before our program. So we will not see you again until after it's happened. Welcome to spring. Enjoy the vernal equinox on Monday, and then join us on the Wednesday. We'll talk about that phenomenon and how that impacts other cultures and how people have used the spring equinox as the beginning of their year and the beginning of the celebration cycles and all of that kind of stuff as part of our program. So thanks for coming. Thanks for attending. We love doing this every other week. Tell your friends and have them join us, and we'll see you next time. Thank you very much.